Okay, so this is my talk, the free will, the false presupposition and testable model. I'm Dr. Mark Hadley. I'm from the University of Warwick. I'm based in the physics department. I'm a physicist, and my usual work is quantum theory. And it's the link with quantum theory that attracted me to this work. And the talk I'm going to give is based largely on this published paper, the deterministic model of the free will phenomenon, and that's where it's published. And the easy place to find this and the whole of this talk, the PowerPoint, is on my web pages, so you can look me up. I'm Mark Hadley at the University of Warwick. And this paper, which did quite a few things which I think were all unique. We'll go through most of these in the talk. I showed that there was no evidence for indeterminism in human decision making, no tests for indeterminism. Then there's this notion, which is in the title of my paper, the false presupposition in the free will debate. I don't know if any of you have heard it's John Searle's famous or infamous comment that he thought it was a scandal that the free will was still unresolved and misunderstood after over 100 years of philosophical debate. And he said he thought the reason when something goes on that long without a resolution is that there was some presupposition that was false, and I think I can show that. I'm going to pose an alien test of how which I would challenge people to apply their models and ideas to. And I propose a test for free will, and bring up a model, and the model makes predictions, which I think all good physics models should do, and it comes up with perhaps one or two surprises as well, which is nice from a new theory. So one of the things that was quite clear when I started looking at the literature, well, not quite clear, it took me a while for it to sink in, to be honest, is that free will's talked about in different ways, and some authors are very clear when they're what they're talking about, but many are not. So one thing the word free will is used for is a phenomenon, and we believe that our decisions are not predetermined. That's really quite a strong belief, and there's research that shows that this is cross-cultural and quite universal. So that's a fact. We do believe that our decisions are not predetermined, and I'm a physicist, so if I see some phenomenon, what do? I try and characterize it and then produce a model, and if I know what the facts are, I can test my model and maybe make new predictions. We're going to come to this more later. So that's one form of free will. It's a phenomenon. That's a fact. We do have that belief, yeah? So if people are talking about free will as the phenomenon, there's no point saying, do we have free will? This is a fact. This phenomenon exists. It's a fact. Yeah? But the other form in which free will is talked about is as an abstract concept, and this concept is that our decision making is indeterministic in a technical sense. So this is the concept that our decisions are not predetermined. They can't be described by a deterministic theory, and this is quite different. So for the abstract concept, you could ask, do we have free will? It's a legitimate question. Is free will deterministic? Well, if this is your definition of free will, if you're talking about the abstract concept, then it is indeterministic. There's not really much issue about compatibility in this sense, yeah? So if you're talking about the abstract concept, and I've got no problem with that, but physicists, we're often doing things like that. So you might talk about dark matter or all sorts of abstract concepts, but different questions arise then, yeah? So one is, does it exist, yeah? So we would look for some evidence, we would design some tests, so we would try and see if the concept have any value at all, yeah? And one thing we need to be careful about, I'll say this now, I'll say it again, and if you read my paper, you can see all the links and references, is that intuition and introspection are not evidence. Awareness of our own decision making is notoriously unreliable. We don't know how we make decisions. We often think we know, and it turns out when you do tests and experiments that that's wrong. Yeah. And the psychologists are well aware of this. Relatively elementary psychology books will give you a whole list of things where we misjudge things, make different beliefs. It flows in sociology and in criminology. When people look at the evidence, identify substeps, remember what's happened, they think they're doing some process and it's not. And then more recently, we've had results from neurology, Libet's famous experiments where he claims to show that actually we make a decision first and we're aware of it afterwards. We are not actually aware of the decision-making process. Now, there's some controversy about Libet's work, but that's not really that important here. He raises the question that we don't know where our decisions are made, and he's right, we don't know. I mean, it may be that we're aware of them, we may be not, but the question is there. And the other thing, which is really fun in terms of awareness of our own decision making, is if you look at stage shows. I love Derren Brown's he's a bit of a magician, but he's a bit more of a psychologist and a scientist. He will influence people's decisions. They think they're making a free choice, and he can time and time again have predetermined what they're going to decide. The money will always be in the other envelope. The number they freely choose will be already written down on his bit of paper. There's a whole range of different ways he does that, but part of it is people think they're making a free choice. Actually, it's pretty well predetermined what they're going to say. So it's really important not to confuse these. Yeah, there are these questions, and some of them don't make sense for one or the other. Yeah, but this is where we're going from. Yeah, so with the I've got a pointer here. You should be able to see my pointer. So with the abstract companies, does it exist? So we need to know what it would look like, what are its distinguishing features, and how can we test for it? Yeah. Whereas with the phenomenon, it does exist. That's dealt with. Yeah, it's the fact that we think this. Then it's what are its characteristics? How do we model it? How do we test the model? How do we make new predictions? So if you're looking for determinism or indeterminism, so I present you with 3 different agents making decisions. Yeah. What pattern of decision making would you look for evidence of indeterminism? A lot of people would say that humans' decision making had free will and was indeterministic, and would have a prejudice that computers, they follow an algorithm, we know what they do, they don't have free will. And forget the words free will for now. How would you actually decide whether it's indeterministic or not? And I've really got to try and get people away from these prejudices that it's a human attribute and that's it. Imagine you had an alien visitor, comes out of his spacecraft wearing a suit. How would you decide whether it was a free agent like us or just a sophisticated automaton? What would you do? Could you ask it questions? How would you know? Yeah. And what I show in my paper at some length, and perhaps a bit boring, so I won't reproduce it here, there isn't a pattern of decision making that would give evidence for indeterminism. It has no distinguishing features. Yeah, it doesn't exist. What would it look like? Well, we don't know what it would look like. There's no test for it. It doesn't have any distinguishing features. We can't test for it. Yeah. Now the phenomenon is completely different. Can we model it? Yeah, I'm going to model it. We're going to see that later, whether you like it or not. Yeah, and we're going to test the model, and we're going to make new predictions. Yeah. And if you start confusing the phenomenon from the abstract concept, you're getting a right muddle of asking the wrong questions or going in a circular argument. So we're going to leave the abstract concept shortly. I'm saying there's no evidence for it. There's no conceivable test for it. the concept of indeterminism has nothing to do with our decision making. There's not a shred of evidence, and there can't be any evidence that indeterminism is a property of our decision making. Yeah, and going back to the title of my paper and Searle's work, indeterminism is the false presupposition in the free will debate. Yeah. Now you hear compatibilist arguments. Yeah, this isn't a compatibilist argument. That's discussing free will and indeterminism, relating the two, and so on. I'm saying it's got no. Whoops. I'm saying it's got no place in the debate at all. It was just a mistake ever talking about indeterminism. It's completely irrelevant. It always has been. Yeah. It's an abstract concept. There's no evidence for it. There's no conceivable tests. It's got no unique characteristics. Yeah. It's not a useful concept. Well, we shouldn't be too surprised by that. I suppose people come up with those as scientists every now and again. They come up with something and we look and think, well, you know, there's no evidence for it, or it's not really relevant. Now, the phenomenon's quite different, yeah? This is a fact. We do have this perception that we could do otherwise, yeah? So what are the characteristics of our decision-making that we give this label of free will to, yeah? We've got this perception that in a situation we could do otherwise. We've got a perception that our choices are not predetermined, yeah? But with very complicated organisms, the environment we're in is changing all the time, yeah? So we've never been in exactly the same situation and done repeated exactly the same decision and come to different outcomes, yeah? We've certainly made different decisions in similar circumstances. I might decide whether I have a piece of cake today, and I might make a similar decision tomorrow, or a similar decision 10 minutes later, yeah? And I might make different decisions. I might make the same one, yeah? But that's unremarkable. That's not indeterminism in any technical sense. I mean, colloquially, we might use the same word, but in a technical sense, that's not indeterminism, yeah? Every computer can do that. We can put it in a slightly different state in an hour's time, or and it'll make a different decision. You can even do it with a clockwork mechanism. I mean, if I had a clock that measures to the nearest microsecond, I can make a decision that depends on whether the number of microseconds is even or odd. It would be undetectable, but it's totally deterministic. Yeah? So,
may I ask a question? Yes, because
yeah.
I didn't get really what you said about indeterminism. If we define indeterminism, that there is no formal theory that can predict, and this is usually understood as giving the notion of non-deterministic events. Let's say in mathematical logic, you know that there are problems which cannot be solved because they are undetermined by any formal mechanics problems. So I don't really understand when you say that indeterminism is not really definable. Could you make this more precise, at least?
No, sorry. Yeah. No, I'm not saying indeterminism isn't defined. It certainly is. There are a lot of theories, physical theories, which are indeterministic. If I'm at the roulette table, or
mechanics so far.
Pardon?
I was saying quantum mechanics, for instance. That's a question.
Well, I don't need to refer to quantum mechanics. If I'm at the roulette table or playing cards, I will use an indeterministic theory to work out what to do. I will say 50-50 chance of red or blue, or 25% chance of spades. Yeah, I will use an indeterministic theory, but I believe that I don't believe those processes are fundamentally indeterministic.
Which process?
Pardon?
Which process are not deterministic?
The ball in a roulette wheel, or the order of the cards in the pack. I think it's very deterministic. I think there's a certain order of cards in a playing, even when you've shuffled, and what comes up is predetermined. But I will still, in most cases, I won't be able to see it, so I will use an indeterministic theory to take my chances at the card table.
Mm-hmm.
So what I'm saying is, you look at human decision making. So it's human decision making I'm talking. What would evidence look like that was a fundamentally indeterministic process? And there isn't such evidence. It's incredibly difficult in quantum theory even to say that the mathematics, in most cases, by most interpretations, the mathematics of quantum theory, the theory, is indeterministic. It predicts probabilities generally. But to say that quantum world, that the real physical world is indeterministic, that's an open question. I'm not aware of experiments that have shown that quantum theory is indeterministic, actually.
Well, I think I have to jump in here, because I think that at least 99.99% of quantum physicists would agree that it is indeterministic. And indeed, to prove anything, you need an assumption, because you cannot make a mathematical proof without an assumption. But if you assume that there is no faster than light influences going on, then you can demonstrate that quantum physics and quantum events are non-deterministic. Yeah. But you have to make the assumption that nothing goes faster than the speed of light.
Absolutely, you're right about that. There are some experiments. I think they're all with entangled pairs, where the environment's isolated a lot, where you can show that there's a contradiction between determinism in some senses and locality. Yeah. Bohm's theory is usually the one that shows actually it can be deterministic, because Bohm's theory is quantum mechanics. It is deterministic. Yeah. So you're not going to...
Yes, but in Bohm theory, you have things going faster than light. You have these hidden variables that go faster than light.
Yeah, sure. To be honest, I'm not terribly bothered whether you can do an experiment that shows that quantum theory is indeterministic or not. Not in this. I'm talking about free will and human decision making. And what I'm saying is you can't do an experiment on humans to show that the decision making is indeterministic.
That's not what I saw on your first slide. But okay, go on.
Yeah, because any pattern of decision making that we do, you could have been replicated by a deterministic system.
Yeah, well, every non-deterministic theory can be made deterministic by adding enough supplementary variables. But I suggest you just go on with your presentation. Thank you.
Yeah. Okay. Thank you. Yeah. So what I'm looking at now is the phenomenon of free will. This is our feeling that we can do otherwise. Our decisions are not predetermined. Yeah. Again, my comments about intuition and introspection, they're not reliable. You know, it is a fact that we don't understand our decision making. Yeah. We have a perception that our decisions are not predetermined, yeah, but that's not evidence for indeterminism, yeah. But it's a fact still. That perception needs explaining. I'm not going to dismiss this as irrelevant. What I'm saying is you shouldn't necessarily take it at face value. Yeah? And another thing which I find probably not with this audience, but with other audiences that are more philosophers, they rely enormously on intuition. And my understanding of science and the progress of science is that most times when we made a breakthrough, it wasn't intuitive. It was counterintuitive at the time, yeah. And the reason science was able to do that and move on is we look at facts, we made predictions, even if the predictions seemed absolutely weird, yeah. And then we do the tests and we look at their results, and that's how we made progress. You know, if you just relied on intuition, you wouldn't even have got Newton's laws. I mean, the idea that you can predict the throw of a spear, for example, yeah, many people would have thought, well, what about if the gods deflect it or move it out of the way. You know, the idea that you can have a humans can have a deterministic theory for the throw of an arrow, or, you know, flight of a dart would have seemed counterintuitive to many people. Yeah. And the more recent stuff, quantum theory and general relativity, very strange at the time. We sort of get used to them. So that's a warning on.
Sorry, Mark. Can I disagree again?
You can.
I think that Einstein was actually guided by intuition a lot, and he had one intuition, that namely determinism was one of his intuition. The other one was locality, and so he couldn't accept Newton's theory of gravity that is clearly non-local. So if you move something on the moon, has an immediate effect. So it was his very strong intuition that helped him to develop relativity.
Right. Yes. No. I would agree with you totally on all of that. What I'm saying is that to the general public, the idea that time wasn't absolute was used in special relativity. Very strange. A lot of people were arguing about it. Yeah, and it takes a genius to decide which bits to challenge, which bits to accept. And Einstein had, I'm quite happy with you using the word intuition. I'm not saying intuition's always wrong. I'm saying it's not a fact. He can't say, I believe this and therefore it's true. You have to what he said was, can I write it down? Can I make predictions? And interesting about his intuition, because in many ways his theory was better than him, wasn't it? Because intuitively he thought it would never be solved, didn't he? He thought this equation was so complicated there'd never be a solution. And then Schwarzschild found one a year later for the Schwarzschild solution, which is probably the most important one. Einstein's intuition was that his cosmology was wrong because it showed an expanding universe, and it turned out to be right. His intuition was wrong. He thought there couldn't be black holes. His intuition said it couldn't be possible because black holes wouldn't be stable, and indeed we know the solution isn't stable over the full parameter range, but we still think they exist. So I'm not. Some people's intuition is better than others. Many people's intuition is right a lot of the time, but to say that just something is believed in or is our intuition means it's fact is not so. But we're scientists. We can solve that. We can decide between one person's intuitive idea and another because we ask for their predictions and we do the experiments. Okay. Thank you.
Okay. If I may again make a remark.
Yes.
You say that our perception that our decisions are not predetermined. I don't really agree that there is no evidence. So if you speak of determined matters, then you know in advance what will happen. So, as I said before, you have a knowable prediction, a knowable theory.
I disagree with
that. But then,
I disagree
suppose, tell me why, if you disagree.
I disagree that you're using this term knowing, and I'm not sure exactly what you mean by that. I don't know what everyone's decisions will be, just like when there's a pack of cards, I don't know whether the next one that's turned up is going to be an ace or not, but it's there, and it's either going to be an ace or it's not an ace. It's predictable. Yeah, it's deterministic. What the next card that's turned up is deterministic. It's determined by what cards are in the pack. I don't know what it is. Yeah, but it's
speaking of determinism, what does it mean? That means that you have a formal theory that predicts. Otherwise, I don't understand what means determinism in a serious way. You have a theory, let's physics say, or other mechanics, which predicts what will happen. Yes. Suppose you have a theory which predicts, for myself, that at a later time, say T1, I'm doing something. I'm taking the train to go to London, say, yes? But then if I know it in advance, you see, I can try not to do what the prediction says.
Absolutely. Yes.
I will try to not to take the train to London. And then you may say, yes, but I'll be forced by the theory, by the physics. But I can always have a mental restriction, you know. Okay, I will be forced to do it, but mentally I'm thinking I'm forced. And then the prediction
you're absolutely right. And what you're describing is one of the facts of human decision making, that whatever decision you're about to make or presented with or has been predicted, you believe you can do something different, and you have a history of evidence that supports that view. And that's exactly what I'm going to come to next.
Sorry.
No, you're not sorry. No need to be sorry. This is fine. I like a bit of discussion, but it's easy for it to get out of hand. So I'm very happy for these points of clarification, and I'll talk about it as much as you like near the end. Yeah. So I'll move on, I think, if I can remember what the next slide is. So it's what you were saying. You could do otherwise, yeah. For any decision we're about to take, we know we could do otherwise. We ask ourselves that question, yeah. And we can change our behavior, just like you described, yeah? Someone challenges us, so like you've just described, yeah? I could say, I'm predicting you're going to do this, and you think, well, we might do something different, mightn't we, yeah? And it's not just me saying it now. You know, we've got a rich history of such decisions and some actions, yeah? So the question, my challenge to model the phenomenon of free will is to have a model that reproduces this, yeah? So here is my test, yeah, in a sense, for free will, yeah. Someone was asking before how you can measure it. So I would, if I look for some action or decision that's unusual or has got no value, or maybe it's even a bit harmful, yeah. So if I asked you to write your signature down, you would probably pick up your pen with your right hand and write your name, yeah. If you're left-handed on this discussion, you'll have to transpose the two, yeah. If you're ambidextrous, you can just be smug, yeah. But if I was to say, could you do otherwise? And you might have asked yourself that, you know, when you're dreaming away in your office, to think, could I use my left hand? And you could do, yeah. That would be a very unusual thing to do. I mean, I say 99%, 99.99% of the time when you have to write your signature, you'd pick your pen up, use your right hand. But you could do otherwise, yeah? And if you challenged yourself to do otherwise, that would change your behavior, yeah? I'll give you another example of, could you put your hand in a flame? I don't know about you, but I've probably done this a few times, thinking, well, could I do that or not? Yeah, I mean, I wouldn't normally, and there was no good reason for doing it, and yeah, but you might do that, yeah. So in response to a challenge, and for no other reason, we might take these actions. So a very rare event, like writing with your left hand, putting your hand in a flame, some changes to being quite likely, yeah. And I say to you, that's how we know we could do otherwise, because we respond to a challenge. And that can be an external one from me, or it can be self-generated, yeah. And these, a 50-50 test isn't a very good one. Lots of things are sort of random 50-50, but this highly discerning test is a very clear example of how we change our behavior in response to a challenge, yeah. So this is my question. This is how I would test my robot for free will. I would ask it if it could put its finger in a flame, yeah. And if it was entirely logical, rational, and well programmed, I mean, why on earth would it? Yeah. Yeah. So here is my model. We consider a decision-making agent. Yeah, and what I'm looking at is in the literature. It's described as a utility agent. So it's goal seeking, yeah. So it's got some internal and subjective goals, and we're going to add an extra goal called independence that's satisfied by responding to a challenge. And this agent that we're modeling here, produce the model of, it can show us that it could do otherwise with introspection, with abstract analysis. It will come to the construction of free will. So let me give it, I've got a picture of it next, I think. So this is my utility agent. it's very general. It's used in all sorts of branches of science to model decision making by humans and otherwise. So it can model social and economic things, and it can be used in AI as well. I'm having a bit of trouble with my pointer, so you'll have to guess what I'm talking about. Yeah. So on the left, sorry, this is the wrong one. So on the left, it's got some external stimuli, maybe some internal ones, and it has a range of different goals, which you might want to be hungry, you might want to be well fed, have enough to drink. You might have more subtle goals like sort of happiness or I don't know, respect, or or you may be tired or something. And the goals have different weightings, and some part of you does some sort of analysis. It may be highly rational, it may be irrational. Around the level of rationality is not really important here, and then some decision comes out. Yeah, you can expand this and make it more and more complicated. We are very complicated. There's a lot of aspects to our decision making, but this is not a bad way to model decision making. Yeah, and then what I do is I adding two more aspects to this. Yeah, one of its goals, one of our things we do is we want to show that we're independent. We value that. We give that some value. It's not necessarily dominant, but it's one of the factors that affects us. Yeah, that we use to help make decisions. Yeah, and the other one is on the left there, as an extra stimuli, there's a challenge. Yeah, the agent is challenged. Yeah, and obviously this requires a relatively complex agent that can at least recognize a challenge to sort of understand what's going on a bit. Yeah, but the details of that aren't actually very important. But now we have an agent that will respond differently when there's a challenge, and that challenge, I've drawn this on this picture as an external one. It could be generated internally. Yeah, there's nothing indeterministic in this model. I could do it with wheels and clogs if they were complicated enough, but I could certainly program that into a computer. Yeah. So we have some predictions for this model. The agent responds to a challenge to do otherwise. Yeah, and that will look like free will to us. Yeah, you'll see it behaving a certain way. You'll be able to ask, did you have to do that? Could you do it differently? And it will behave differently. Yeah. And that doesn't need to be human. That could be a suitably programmed computer. I don't know if any of you watch Futurama. Do you know Bender in Futurama? You all got your microphones off, so you won't be able to tell me. But that's depicted as a robot, a deviant robot, but he misbehaves and goes a bit astray. But it behaves like a human in this sense. So that would definitely respond to the challenge to do otherwise. Yeah. One that's not so good is Spock in Star Trek. Was supposed to be totally rational. He would always do the most logical, rational thing. Not very convincing because he's had such a human form. But if he was truly logical and was asked, will you put your hand in a flame or do something illogical, he would say no. Why should I? Yeah, he wouldn't be acting much different to a characteristic robot. Yeah. So another prediction is that if an agent doesn't respond to such a challenge, it will appear not to have free will. Yeah, and you can do all sorts of things with finely judged decisions, and a lot of in the literature there are things called two-stage models where some small fluctuation makes a difference. Yeah, they're not such good tests. The best tests are these highly discerning tests where this challenge makes an enormous difference to the probabilities of what's going to happen next. Yeah, and here the probabilities are nothing to do with quantum here. The probabilities are just because we're very complicated. We don't understand everything. So just like the ball in the roulette wheel. Yeah, but those highly discerning tests give a clear signal. Yeah, and as scientists, we're used to designing highly discerning tests. Yeah, it's about getting a good signal to noise ratio. Yeah, and then something I referred to at the beginning about earlier on is how would you test an alien visitor to decide whether it had free will or not? So this is, I would use a highly discerning test. I would look for some behavior in this entity that seemed to be it would never do, or it didn't like, and I would challenge it to do differently for no good reason, and I would see if it was able to respond to that challenge. Yeah. I think there's a lot of prejudice about what does or doesn't have free will. You know, I'm talking about the phenomenon of free will here, and I think one of the best ways of testing this, which I alluded to a bit earlier with Bender in Futurama, is to use cartoons where you can have behavior and the physical and the physical form are quite independent. You can have fluffy balls of something and you can they behave, and I think if you wanted to do tests about whether this was a good model, this would be an excellent way of doing it. Trying to remember if I haven't. How am I doing for time? Okay, should be all right. There's I didn't try and give you a surprise prediction from this. You imagine some tribe out in the jungle, if you look, if I apologise for these stereotypes I'm introducing here, who perhaps do sacrifices to the volcano or to the god of the wind or the sea. And they're assuming that volcano, the god that they're praying to, has free will. They're assuming that the sacrifices will make a difference. They're asking one way or another to do otherwise. And they're doing that, I believe, because they've seen a pattern of the explosions. They're believing that there's a correlation between what's asked for and what happens, and therefore they attribute it to free will. So there's an example of a false attribution of free will, which is what my model would predict. So I think I've dismissed the abstract concept of free will as basically irrelevant and misguided. I've then got the phenomenon, and I've modelled it as a scientist would, made predictions, so I think I can test it. So why did this take so long to understand? Because I haven't used any fancy science, yeah? I mean, I haven't used quantum theory. I haven't needed to use some complicated equations from chaos theory. What I've applied on here is the scientific method. I've looked at the facts, built a model, tested it, compared it with the results, yeah? And this is where I think we've gone wrong. This is why we've had this false presupposition. One reason is the language. Yeah, we've used language like that our decisions aren't predetermined. We might say they're indeterminate. It's the same words that are used to classify scientific theories. But when we're used in a technical sense for the scientific things or as philosophers, they've got a very precise meaning. Things don't necessarily mean the same at all. Yeah, I said before that our idea that things aren't determined are that in different circumstances, on a different day, if I changed my mind, if I thought about it more carefully, in different circumstances, I would make different decisions. Yeah, that might be indeterminate to us, and that might be the normal use of the word. But in a scientific theory, that is not indeterminism. That's just normal, complicated system in a rich environment. Yeah. The other thing we've done is relied a lot on introspection. Yeah. Yeah. It's not, like I said before, it's not always wrong, but we can't be sure of our own decision making. We don't quite know where and when we make decisions. We can't be sure that's right. Yeah. And we valued this intuition more than the evidence. Yeah. So there's been some amazing theories produced of two-stage models with different weightings and quantum fluctuations. Yeah. But they do, you know, these models have been constructed without people first thinking, well, what are the facts here? What is it we got to explain? And these people who think they've solved the free will problem and got these models, and they've never ever tested them. They believe in them, no one else does, or no one's convinced. Because they haven't looked at the facts and thought, what is it we got to predict? They've started with an abstract model, built an example of it, and it's sort of a circular argument almost to them. It's got nothing to do with human decision making. So I think that's where I am. That's where I'm ending. I'm going to try somehow or other to close this to get myself back to you. Sorry, Matt, I'm looking for my little icon that will get me back to what's its screen mode. Ah, there we are, got it. I think we're back to normal now. Do you think we're back to normal?
Yes, it looks like.
Okay.
Mark, thank you very much for an interesting lecture.
You're welcome.
And I guess we have time for questions and the comments. So please feel free and ask Mark questions.
I have a question. Your thought experiment requires that you can communicate with the free will agent.
Yes.
But what would you say, for instance, with a dog or a cat? Do you think they have free will?
Yeah, no, that's right. I think it's an interesting question about a dog or a cat. I think in the literature most people are assuming they don't have free will. I mean, I've had a bad dog where whenever you picked up the phone and were busy, it would then start doing something naughty. So this is what I would look for. You mean, I gave that example of putting your hand in a flame. I think if I were to see a dog or a dolphin or something doing something that had no value for it at all, and maybe it was a little bit harmful, and then you'd think maybe that it was making its own decision about whether to do that. Maybe it had a choice making there. I'm not sure. I don't really mind what the answer is there, but I would apply the same sort of test. I would look for something unfavourable. So what I'd be doing there, I couldn't communicate with them. I would be looking for signs that they were internally challenging themselves and changing their behaviour. And indeed, dog training sort of relies on that, doesn't it? It does rely on changing their behaviour, getting them to change their behaviour, changing the algorithm in a way. Yeah.
Yeah.
Okay. Mark, maybe are you done, Antonio?
Yes.
Okay. So, well, maybe I can also ask some questions or comments.
Yes.
Well, so first, thank you for the lecture. It was very interesting. I guess there are many points on which we agree. I guess the basic disagreement is on the, you say, valuing explanations more than evidence. But how can you value evidence if you don't have already a theory? You need a theory to have evidence. And to develop the theory, you have to start from something.
I agree that they're related. I don't think you need a theory to evaluate. I can have some puzzling phenomena. Our physics department is doing it all the time. They're presented with some puzzling phenomena and someone scratching their head and saying, how do you explain that? And then they go away and get a theory, but then they compare it with the facts.
But I think you must have some kind of elementary model to start with. But anyway, my disagreement probably would be that I'm valuing explanations overall. I don't want just to have a kind of instrumental theory or model that reproduces facts or evidence. I also want something that provides explanations that talk to me. And I think that these kind of requirement that I want actually to understand the nature, understand the world, going beyond just developing technology, and that requires, how can I even decide that an explanation talks to me or not? And that is something where I need some free will that comes first, as I was saying yesterday, in order to decide that this is a theory that I can indeed buy, not in the sense that it makes the correct predictions, but that it really talks to me and that it illuminates my understanding or part of my understanding of the world. And so if you take the me away, or the consciousness, as we were saying yesterday, I'm not sure anything is remaining. What is left over if you remove all our consciousness?
Well, I think what I would encourage you to do is have a look at that model that I produced of decision making, which can do otherwise. Yeah, that is responds to a challenge, and try and compare that with your own decision making and see if you can find a fault with it. Find something that you can do with your decision making that isn't matched by my model. I expect you'll find something because it's a very simple simple model, but I think it captures the essence of it. So what decision making can you do that you would call as free will that my model couldn't do?
Well, I mean, you have to program your system or your robot or whatever. At some point, you had this communication to the outside.
Yes.
Suddenly it says, "Oh, yes, I have understood it. That's a good explanation that speaks to me." And you can certainly program a computer to put that kind of statement on the screen, but I don't think it comes from inside the computer.
Well, it wouldn't be coming from outside, would it? Once you switch the computer on, you could bury the programmer under the ground. What happens afterwards is coming from the computer.
Yeah, but it has been put into the computer by yourself or by someone.
Well, that's where the prejudice comes in. You feel you know how a computer works and how it'll generate a decision. You don't know how your brain works, and you're assuming that they're completely different, or you're applying different standards to them. There is no factual reason to believe that the way your brain works is any more or less predetermined than a computer.
Well, without such a prejudice, I agree. It's a prejudice, but I think it's a necessary prejudice for.
Well, that's why I introduced this alien test. So, there's my question to you: if an alien gets out this spacecraft, is wearing a spacesuit, how are you going to decide whether it's got free will or not? You made this prejudice that the computer doesn't.
It might be very difficult, but my question will be.
Well, it's not difficult. Is it difficult or impossible?
Well, presently, I guess the fact is not only a decision process, but consciousness, because free will is a conscious decision process. So you need the consciousness, and I don't know how to.
You mean self-awareness? I have a lot of trouble when anyone uses the word consciousness because it means so many different things, and often it's just a way of getting away from something. But do you mean self-awareness?
Yes.
Okay. Well, you can have self-awareness in a computer. My computer will tell me all sorts of things about itself, and you can get it to tell me about its thought processes as well. I don't see that as needing any fundamental physics. I mean, without a doubt, my model can be improved. What I'm saying is there is nothing in this other than a sort of programming. Yeah, it doesn't need new science.
Well, I just don't believe that an automata can understand itself. I think that we are facing here some kind of, okay, it's not Gödel in a formal sense, but Gödel-like statements which are just sitting on its own head, and that doesn't stand.
Okay. Most computers don't handle abstract concepts or don't handle them very well. I mean, with AI, more of that is happening. I think if you look at my model and allow it to build up a history of decisions and challenges and that, and then if it was able to handle an abstract concept like indeterminism or free will, it would look at its history of decision making and start telling you that it had free will. And I think the computer people and their what they aspire to is run ahead of philosophers a lot. I mean, I was at university 40 years ago and philosophers were telling me that they could prove that a computer could never play chess or never beat a person, this and that. And we used to say, you have a calculator, it'll multiply numbers, but it'll never do an algebraic expansion. And now they're routinely doing algebraic expansions, simplifying expressions and solving equations. And that can all be handled by computers.
I agree, and it is fascinating all what these computers can do today, and they certainly mimic a lot of our behaviors in an impressive way. But that's just a simulation. You can be in a flight simulator, and as long as you are inside the flight simulator, there's no way for you to know whether you are in a simulator or whether in a real plane. You know, you may have all the screens that give you all the sightseeing and all the shakes, and everything is so there's no way to see the difference as long as you stay inside this flight simulator.
But
that doesn't mean that the flight simulator is actually flying.
Yeah, no, sure. There's a big difference between a simulation of something and the real thing, yeah? And the reason I was happy as a physicist to tackle this is free will is got a neat description. It's could do otherwise, yeah? It's about making decisions and whether you could do, the agent who makes the decisions could do otherwise, yeah?
Well, so you always avoid the word
this computer model doesn't simulate making decisions. It makes decisions. So it's not a simulation. Now the question is,
not consciously.
I don't think the definition of the expression of free will doesn't involve the word consciousness. It's discussed independently of consciousness. It's about whether you could do otherwise, and my model could do otherwise.
Okay, maybe I agree on that, but I don't think your model can do otherwise consciously.
Yeah, I'm not claiming my model is conscious. I've got another paper in progress on consciousness, but that's a completely different matter.
I think they're connected. Anyway, thank you very much for that presentation.
I've heard people say before that they were connected. It took me by surprise the first time. Yeah.
Well, there's certainly one thing about which we certainly agree, namely that indeterminism or determinism has no place in the debate.
Thank you. I'm very pleased to hear you say that. Yes. Okay. I mean, that's 99% of the debate dismissed by the two of us, isn't it?
Yeah, I mean, I said, I think, okay, I didn't use the same words, but I guess you understood the same about determinism and indeterminism that has no place in the debate.
Absolutely.
Okay, so that's the part we agree on. Then, of course, we also maybe on the consciousness something that we disagree on, which is all fine. And then looking forward to your next paper and maybe the following one, because at some point you have to bring consciousness and free will together.
Yes, fair enough.
Okay.
Yes, one step at a time.
Good.
Thank you.
Thank you.
All right, thank you very much. Any additional questions?
Yes.
Comments?
Can I have
Dr. Sosek.
Yes, thank you. I think that the problem for me, at least, is what is the more exact definition? What is the free will? I would like to present a simple example: a computer program using the random generator inside.
Yeah.
No, not pseudo random, but some sort of the random generator. And this is surely non-deterministic, the output of such program. But,
yes.
But can we speak about the free will? I think surely not. So that I think the free will can be attributed, this property can be attributed only to human to persons, to human beings. There is a question with the application to animals, but so it is clear that there is no connection between determinism and free will. But what is missing, at least for me, is what is the free will defined in some more exact term?
Well, the point is that we have something that we call free will, and it is believed by people of widely varying educations. It's not very precise. People have a feeling that they can do otherwise, and that is the phenomenon. If you're trying to describe something more precise, I'm not sure what phenomenon you're describing. People just have a feeling that they can do otherwise. My model does that. quantum theory has nothing to do with it. Yeah, I mean, I could have a computer that made a decision based on what time my clock said, or I could have one based on what the output of a black box was, and it wouldn't matter whether the black box had a quantum generator in it, or a piece of clockwork, or a little girl giving an answer. I mean, you wouldn't know the difference.
Yes. Thank you.
Okay.
Okay.
Thank you very much. In a way, I think, Mark, if I'm correct, your model is very, very similar to what was called the Chinese room problem with artificial intelligence. Can you comment on that?
Tell me about that a bit. I'm not sure what you're referring to.
I'm referring to the Chinese room, when you have the question how to distinguish the machine intelligence from the human intelligence.
Yes, that's my model isn't based on that, but my arguments, and particularly my dismissal of indeterminism in a scientific sort of way, is based exactly on that model. Yeah, people have looked at decision making from humans and suddenly got this abstract concept of indeterminism, and I'm challenging them. Why are you talking about this? Do your experiment that you've just described, not for artificial intelligence, but for free agency, and show me what you would be looking for. And then it's vacuous. There is no pattern that would do that. Yeah. I would welcome that. If someone comes to me and said, well, they would test my free agent by asking it this, and then that's how they would decide. Yeah, in some ways, I've given you an answer to it, haven't you? Because I've told you how I would test for free will.
Okay, Mark. Thank you very much. Thank you very much for a very interesting lecture.